Hello friends, in this video I'd like to solve the following problem from the Berkeley Math Tournament Calculus Test 2022, problem number 6. We wish to find this crazy looking definite integral from 0 to pi over 3 of secant of t times square root of tangent of t times square root of tangent of t times square root of tangent of t sine of t dt. Okay, so this problem is not very hard. It looks daunting, but it's not very hard. My hints: first, get rid of roots by expressing them as powers with rational exponents, and one good substitution will do the trick. So give this problem a try, and I will see you in a minute. Okay, so first, you know what, maybe I will first consider just my expression with roots and so on. Not to write the symbol of integral every time. Okay, and I will eliminate roots, and also I will change every function to sine and cosine. Well, secant is by definition 1 over cosine of t. Here I have, let's see, tangent is sine over cosine. Here is tangent is also sine over cosine. Here is also sine over cosine, but we have additional sine. And here we have power 1/2, power 1/2, power 1/2. Very well. So I have 1 over cosine of t. And now let's take a look. Here I have sine times sine of t, so it's sine squared, but sine squared to the power 1/2 is again sine, because we are dealing with interval from 0 to pi over 3. So we have sine of t, cosine of t, sine of t, cosine of t. And here I have sine of t, cosine to the power 1/2 of t. 1/2, 1/2. Very well. 1 over cosine of t, sine of t, cosine of t. And now here I have sine times sine, it's sine squared, but sine squared to the power 1/2 is again just sine. And here I have cosine of t times cosine to the power 1/2 of t. It's cosine to the power 3 over 2, but I'm raising it to power 1/2, so it's cosine of 3 over 4 of t. Okay. And now again, sine times sine, sine squared. By here I have power 1/2, so it's just sine. And in the denominator, I have cosine to the power 7 over 4. To the power 1/2, it's cosine of 7 over 8. Very well. And now what do I have? I have sine of t over, well, cosine to power 15 over 8 t. And writing it with without denominator, it's sine of t, cosine to the power minus 15 over 8 of t. It looks much better in this form. Very well. So now what I want to do is just to integrate this function from 0 to pi over 3. And I will make a suitable substitution, because notice that if I differentiate cosine, I just get sine. So that motivates the following substitution. U will be cosine of t, then du becomes minus sine of t dt, and what happens to our bounds of integration? Well, since t was from 0 to pi over 3, if I put 0, I have 1, because cosine of 0 is 1. If I put pi over 3, I have 1/2. So, the very same integral can be expressed as integral from 1 to 1/2. Sine times dt is minus du, and I have here I have u to the power minus 15 over 8 times minus du. I can use this minus to change the bounds of integration. And now I have an elementary integral. Remember that integral, maybe I will write it, integral of u to some power alpha du, it's u to the power alpha plus 1 over alpha plus 1 plus c. So this integral becomes u to the power minus 15 over 8 plus 1 over minus 15 over 8 plus 1 evaluated from 1/2 to 1. And that is 1 minus 15 over 8, it's minus 7 over 8. So I have 1 minus 1/2 to the power minus 7 over 8 to the power, well, minus 7 over 8. And writing it, I will write it in different form to simplify it further. Well, since I have minus in my exponent, and I have minus here, I can write it as 2 to the power 8 over 7 minus 1 over, sorry, not 8 over 7, but 7 over 8. 7 over 8, and here I have 7 over 8. And that is just, I can take 8 times 8th root of 2 to the power of 7 is 128 minus 1 all over 7. And that is my result. That is my result. Going back to my problem, this entire integral happens to be just this number. And that closes our problem. Thank you for watching, and I will see you next time. Goodbye.